Hello friends, today we are going to discuss about the implementation of stack. Stack is a linear data structure which follows a particular order, and that order is called last in first out. Let us have a look how we are going to implement a stack. Say for example, we are trying to allocate some memory space where we want to insert some elements. Say for example, these are the index 0, 1, 2, 3, 4. That means there are 5 different places where we can able to store some elements. So, this is these are the index, okay, and here is another variable. The variable is named as p, and p will take care of the index value where we have inserted the last element. In case of stack, we have only one end to enter the values, and the same from the same end the values will be deleted. In case of stack, the insertion is named as push and the deletion is named as pop. Now, we have some elements. These elements will follow a particular order that a stack follows, that is last in first out, or it also can be called as first in last out. Say for example, I want to push an element, the element is 2. So, what will happen? What will happen? Initially, we are initialize p as -1. We are thinking the value of p which is representing the index, that is -1. Now, what we will do? We will increment, if we want to insert any element inside p, first we increment p by 1. So, p is now 0, p is now 0. So, at 0th place, say for example, the array that is int val, which is of size 5. So, in value of p, in this place we want to insert 2. So, what will happen? This location will be filled with one value, that is p. Now, again if we are, now the value of p is 0. So, p is pointing this location. Now, we want to again push some element, that is say for example, I want to push 30. Then what will happen? The 30, before pushing the element 30, I will increment the value of p. P will be incremented by again 1. So, p is 1 now, that means p is indicating this location now. Okay. Now, here at value of p, in this location we will insert 30. So, what will happen? 30 will be present in this location. Now, this way if we again want to insert push 26, then again increment the value of p. So, p will be incremented by 2 at second index of the array val. We will have this particular value, that is 26. P is pointing this location. This way, for inserting, that means for whenever we are trying to push some element, we will always increment the index value where we are trying to insert the element. We will insert here, and again if we are trying to insert say for example 50 will be inserted. So, first p will be incremented by 1, that means the index will be inserted or incremented by 1, and in that place we will insert the value. Now, in case of pop, so in case of pop, what we will do? We will go for the decrement of the index. because all we know that whenever we are trying to delete some element, the value is not actually deleted, the value is only the reference is deleted or disconnected. The value is only deleted when the place is replaced by some another value. Say for example, I want to pop, say for example, I want to pop some element. So, what will happen? So, P is indexing this position. So, that means P is now this is now 3, and now we want to pop the element. Now, what will happen? I will just decrement the value of P. So, I will make the value of P as 2. So, I will decrement the value of P by 1. Again, if we want to pop the element, then what will happen? I will, if I want to pop the element, then I will just decrement again the value of P. So, P will be P minus 1, and this way we will be here. So, 2 will be 1 now, that means P is indicating this place now. So, at any point of time, sorry, P is right now at this place. Okay. So, at any point of time, if we want to show that how many elements are present in my stack, that will be represented by from index 0 to index P. So, okay, thank you.